Hello, testing 1, 2, 3. Hello. Assalamu alaikum everyone. How are you all? We're just waiting for other people to join, and afterward we are going to start our session. All right, I believe my screen is visible to you all now, and sound is should be very much clear. Thank you, Hamza, for prompt responses. All right, so people are joining. And let's start our topic that was previously we were talking about different type of storage devices, and we started it with the internal storage devices, the primary and the basic storage devices. We did little talk about the differences in the primary memory and the secondary memory. Let me enhance size a little bit. All right, we did talk about the primary memory and the secondary memory, and we did talk about there is a difference between the offline storage devices and the online storage devices in the secondary storage. Afterward, we need to explore each and every part of primary storage, secondary storage, and offline storage devices. So we did talk about the storage types, RAM and the ROM, and then we are going to see that in the secondary storage we have hard disk and the solid state drives. Afterward, we are going for the offline storage and attachable and detachable, most probably the word examiner is going to use. So इतना तो कोई trouble हमें नहीं होगा. Definitely the word they are going to use, offline or detachable or whatever, we might not have any trouble with it. They can use the word internal and external as a part of the command words or keywords they are using usually. So the list of the keyword I am going to send it to you as well, that what specific keyword if you you're going to write, or maybe the description or explanation is there. So what should you write? Now we were talking about straight away. I'm coming to the one which is this one type of RAMs straight away. The application we have already seen that we are using it, and in our desktop, laptop, smartphone, parallel devices such as printers and the pocket calculator, digital watches, and each and every digital stuff which should hold some information, which might hold some information for a while. Okay, there is a question about the assessment. I'll let you know at the end of the class. Please hold it on. So we were talking about the applications and the uses of RAM, and there are two type of a RAM. We have a static RAM and the dynamic RAM. We are going to start it with the dynamic RAM, which you people have more often either used or see, or most probably in your laptop or desktop devices, you have most probably increased it. So why the type of RAMs are different? This one, the static RAM is somewhere inside the internal part of the microprocessor, or it is very near to microprocessor, whereas a dynamic RAM is uh, is another part, which is again we are going to install it or fix it on motherboard, which is usual on our any electronic device. So now why we have multiple RAMs, different type of RAMs. Specifically, I'm talking about the dynamic RAM. So just because the RAM evolved for speed, and it says speed and speed, the main problem is the microprocessor we are using is a super fast. Any other device, if we are going to make it with the technology we are using in the microprocessor, the problem is that if we are going to make it like things similar technology on the microprocessor, it will be too costly. So there's a problem of the cost effectiveness. That's why we are trying to increase the capacity. We're trying to increase the speed of that particular devices. Now, as you can see that we have type of RAMs. There are many more. सिर्फ इनके अलावा जो यहाँ लिखे हुए. In the static RAM, we have L1, L2, and L3 caches. We are going to talk about it later on. Specifically, we are going to start it from the dynamic RAM, which is in very old computers. We were using SIM. There was a time once we were using RAM memory. Then we switched it on to DRAM. Afterward, SDRAM is there, and the DDR. So the DDR part, you people must have heard about it now, because we are in the age of this DDR. ये सब लोग जो है वो obsolete हो चुके हैं. We are not going to use it anymore. Sort of they are comparatively, they are very slow if we are going to compare it with either the DDR, the first one, which is used in 1998 and till 2003, the computers coming up in the market. So as you can see that there are multiple type of DRAMs, and we are going to specifically talk about these DRAMs. SODIMM is a small online memory model, which is used for laptops. थोड़े से shrink होता है size में. Okay, DDR, DDR2, DDR3, DDR4, DDR5, all are just because of the speed factor we wanted to use. We do have these DDR1, 2, 3, and 4 images sort of available. Not the actual image, but there is a thing that I need to talk about in the DDR section. Okay, dynamic RAM. Whatever the dynamic RAM is, as you can see that dynamic RAM, we have multiple dynamic RAMs. So the dynamic RAM we have in the market, or we were using from quite a very long time since it was first introduced. So are consist of millions of transistors and the capacitors. What these capacitors and transistors are doing inside a dynamic RAM in a memory chip. Okay, capacitor. Please note it down. The capacitor, this holds a bit of information, 0 or 1. The capacitor is going to hold either whatever the value you wanted to send it to the computer, 1 and 0. So it is 1 or 0 means that we are storing bits, right? So most probably 8 capacitors are going to have a byte on it, and you can try to understand that if I have MBs of data or GBs of data, so how many memory capacitors I need to have on it. So that's why there are millions of transistors and capacitors are embedded inside a memory chip. Now, what the transistor is going to do, once if it is the capacitor is going to hold the information, transistor is going to act as a switch. It allows the chip control circuitry to read the capacitor or change the capacitor value. So whatever the value is stored inside the capacitor, if you wanted to change it, means you wanted to overwrite it, or you wanted to release that particular capacity, particular thing from the memory, we are going to use as a transistor. It acts like a switch. Switch kya hota hai? Like I have a light switch over here, I have a computer switch through which I can either start or stop things. So these are the ones which we are talking about, that it is the transistor is going to act as a switch, which is going to allow either 1 or 0 to store inside the capacitor. So I hope that these two lines are very much clear, but there is one twist over here, that is the type of RAM needs this type of RAM, the dynamic we are talking about right now. After this, we are going to talk about the static RAM, but this type of RAM which we are using right now in as a dynamic RAM needs to be consistently refreshed. Okay, this is something which is more clearer to the people, जो कि चीज़ों का although आप में से कोई भी नहीं होगा, लेकिन बात कुछ लोग होते हैं as a student, as they are repeating things again and again, जिसको वो rectification का एक word use होता है, थोड़ा सा बुरा सा word कहलाता है एक तरीके से अच्छा भी है, एक तरीके से बुरा भी है. So the RAM is going to do it. It is going to refresh it again and again and again and again. So it might hold that value, that particular value. Let's suppose it is holding in a capacitor. In a capacitor, it is holding 1. So it needs to be refreshed again and again to remember that I am holding a 1, I'm holding a 1, and I'm holding a 1. How many times? That is, the capacitor needs to be recharged every 15 microseconds. Otherwise, it will lose the information. So, mind it. There are two measurements. One is about the capacitor, the overall capacitor, that is 15 microseconds. It is going to refresh itself, and we are going to talk about another thing in nanoseconds later on, and after once we are talking about static RAMs. So उधर और इसमें confuse मत होइएगा. ये अलग values हैं, वो अलग values हैं. We are directly talking about right now capacitor which is inside the dynamic RAM. So it needs to be refreshed. Okay, if it wasn't refreshed, most probably. So क्या होगा? The capacitor charge would leak away very quickly, leaving every capacitor with the value of 0. So transistor is not going to do it now if it won't refresh with the 15 microsecond. Who is going to do it? the capacitor. If it is not, then the charge will leak and will fill up with the zero with every capacitor inside your memory. So there are few trouble once we are using too many applications open at our computers. So बाज़ औक़ात वो held up हो जाता है, hold हो जाता है, and that is most probably one of the problem might occur about the capacitor. It is not mandatory that this is the one which is happening inside the memory, but it is one of the possibility we have. So you need to have these note these things down. Although I'm going to send it to your GCR Google Classroom as well, but you need to copy it down in your notebooks as well. Okay, there as we did talk about that, there was a DDR in 1998, and the fifth one is basically is not available right now. Image मेरे पास इस वक्त available नहीं है. As you can see, there is a difference between each and every memory. Although the memory chips are same most probably, but there is a cut on the microprocessor, the board. There is a ruler over here at the bottom. You might not, it's not clear to me, तो आपको भी तो और clear नहीं होगा, but it's a ruler, simple ruler. As you can see that it's slightly over here. Once they change from DDR or DDR1 to DDR, what they did, the cut was slightly toward the left side, and once they change it and evolve it to the DDR3, the manufacturer, what they are doing, the cut is now over here, and once we are at DDR4 from 2014, DDR4 cut is in between DDR1 and 2. So what is coming into your mind after this? What is basically happening? Why they are going to change it? Is there something with the data flow, or do you think that there is something, some other other reason for it? Anything comes to your mind? The cut is different. Most probably in DDR5, I haven't find it this type of a particular image. Otherwise, I'll put it over here. But I think that they are going to move it either over here or there somewhere. All right, there is a question about DRAM is divided into 3 more categories: SDRAM, RDRAM, okay, and DDR. उन्होंने लंबे नाम लिख दिए हैं अभी, ठीक है, DDR1, 2, and 3. Yes, once we have started it. So dynamic RAM, we have one is SIMM, single inline memory module. इसका नाम जो है वो इसी की कंपनी के नाम पे था, Rambus inline memory module, and then we have a dual inline memory module, and then SDRAM and the DDR double data rate 2, double data rate 3, double data rate 4, and the 5. So yes, we do have categories, but you don't have to go for it. Most probably in A level, it is complicated, but what you need to understand only, as I am talking about, that in a DRAM, what you need to see that there is a capacitor and a transistor, and you need to hold the information, you need to check the information, what the capacitor is doing, what the transistor is doing, and the refresh rate. It needs to be refreshed to hold that data within 15 microseconds. That's all you need to understand. ये क्या क्या होते हैं, क्यों होते हैं, इतने सारे अलग अलग होल्स क्यों हैं, क्या वजह क्या है, अलग अलग टाइप के क्यों हैं, एग्जामिनर इज नॉट गोइंग टू आस्क यू, ठीक है. दैट इज फॉर आवर ओन इंफॉर्मेशन और आवर ओन अंडरस्टैंडिंग, ठीक है. तो ये वाला पार्ट मोस्ट प्रोबेबली एग्जामिनर आपसे नहीं पूछने वाला, बट ये वाला पार्ट, the previous slide, this one is definitely going to we are going to examine you on it. So why it is the one, अगर मैं यही वाला बोर्ड पे, सेम पुराने बोर्ड पे नई चिप लगा सकता तो मेरा बोर्ड अपग्रेड हो जाता sort of, and then the DDR3 and then the DDR4, so I need to change each and every part of my computer, and then I can use the new RAM DDR most probably. And that's why they are going to change it again and again. It's all about the business. Yes, we have a DDR1 and a DDR2 and I have DDR3. Okay, this is a very good question why they are doing it. But as I told you that this is all about business. The manufacturer are basically, once they are creating a newer version, if you are going to install it, if you are going to place it on your previous motherboard, definitely you're going to get some data, some speedy data on it. But as if the hole is somewhere else, you need to change your board as well. So you're upgrading everything basically, and once you're upgrading everything, it means that you are investing some money, investing some amount on it. So that's the whole reason. It's all about business. Now let's move on to the SRAM. Okay, what the SRAM is? All right, this is, yes, you're absolutely right. A बहुत close observation है. I think Faik is there. किसकी है ये? Mohammed, Hamza, or whoever it is. क्या नाम है? Mohammed Faik. Faik is talking about that here we have rounded shape holes. Here we have different type of holes. What these things are going to do? Basically, once you are going to put it on motherboard, so the stopper or the lock which is going to grab this particular RAM, dynamic RAM. Previously it was a rounded shape, but after the DDR3 is, after once the DDR3 is coming, the hole, this is just a lock which is going to hold this RAM from left and the right area. So they're making it in a different manner. That's the whole story. So इसमें खास फर्क as such नहीं है. Yes, you're absolutely right. The observation is very good. Okay, we are going to talk about now the static RAM. Static RAM is somewhat a little bit different from the dynamic RAM. It is very fast memory, a very expensive one. The point number 3 is very big in working, but very small in the size because it's available in KBs and MBs right now. Okay, as you can notice that, excuse me, in our previous slides, the DRAM is going to hold data in capacitor with the help of transistors. Here, we are using flip-flops to hold a bit of memory inside the data. Okay, this is the outer look of the SRAM, which is again on some motherboard, and this is the inner look of our SRAM. Okay, another question is SRAM may overload several times Basically, it isn't. It is not. Why? I'm going to tell you. Okay, this is going to use a flip flop. Okay, flip flop. What's a flip flop is? It's in our next slide. As you can see that this is somewhat a logic circuit. आप लोगों ने इनको पढ़ा हुआ है. Basically, this is a device. The flip flop. Excuse me. The flip flop. Yes, these are the NAND gates. So, excuse me for a while. एक मिनट रुकिएगा. इतनी देर आप इसको जरा से डीट कर लें. Sorry about that. Okay, we were talking about that there is a difference between SRAM and the DRAM. What is basically happening? Okay, I'm holding on this particular slide, but basically what is happening once we are going to enter some data with the help of just imagine, just visualize it. Once you are going to click on a particular key on my laptop or on my desktop or any other device, that particular data is going through input device to the microprocessor. Okay? But in between there are many things. It's not directly going to the microprocessor. What the main things are? Basically, it is going through a RAM from the input device. It's going through a RAM. RAM is going to pass it on to the SRAM. Then it's gone most probably in some cases gone through ROM as well, and then the microprocessor. The speed factor of my input device. Basically, if I am going to compare it with the one which is my microprocessor, so I would say that my input devices are too lazy, too pathetic in speed as well. But once I'm going to talk about the RAM, it is more faster than I'm talking about DRAM. It is more faster than the input device. Afterwards, we have SRAM, and then SRAM is more faster than the DRAM. It is more closer. The speed factor is more closer to my microprocessor. So, होता क्या है कि information आपका जो सवाल था ऊपर कि वो overload हो जाएगी. So, overload इसलिए नहीं होती कि it is going to grab the data from DRAM and going to pass it to the microprocessor. ठीक है? So, it's sort of a bridge. It's sort of a bridge which is going to hold the data, going to pass it on to the microprocessor, and the microprocessor is going to return it to the SRAM. SRAM is going to again give it to the DRAM, and the other processes are going on. So these are few sort of bridges. Okay. Okay, so this is the SRAM, how they are going to hold that data in the SRAM. We are using NAND technology to use it. ठीक है, और इसमें एक बड़ी important बात ये है कि with the help of NAND gates, we are holding the information not in just in SRAM, but we are going to study it. The flash memory, or जिसको आप लोग USB कहते हैं, the flash memory is also going to use the NAND circuits to hold that data, this particular data, inside that memory chip. Okay. 10 minutes remaining. So now we are going for that typical access time of SRAM is 25 nanoseconds. Okay, the static RAM is going to talk to the microprocessor most probably in 25 nanoseconds, whereas the DRAM is basically working on 60 nanoseconds. So this is 60 nanosecond is much higher than the 25 nanoseconds. Almost this is the more than the double speed of SRAM. Okay, where we are using this type of memory. Okay, we are going to use the SRAM in processors cache. Cache or cache दोनों पढ़ा जाता है. It is a high-speed portion of the memory. It is effective because most programs access the same data or instruction many times by keeping as much as of the information as possible in the SRAM. The computer is having the access slower DRAM. So hota kya hai, we are going to hold that data, particular data, going to send it to the microprocessor. Microprocessor is again going to send it to the SRAM, and we are going to most probably ship it to the DRAM or any output device as well. So that's how the information is going to flow. Okay, this is flip-flop, and there are many type of flip-flop. Once you are going to study it in your engineering subjects, so there is a JK flip-flop, and there are many more. So ये हम इसको JK flip-flop कह सकते हैं. So it's a complete device which is going to hold that particular data in a bit pattern, by the way, not in bytes still. Okay, the advantages of DRAM over SRAM. We do have a few advantages. In the DRAM, it's much less expensive than if we are going to manufacture the SRAM, because of the technology is similar. In the SRAM, the technology is almost similar as how the microprocessor we are going to hold some data. The DRAM is consume less power than the SRAM, and the good thing is they have higher storage capacity than SRAM as well. So ये 2-3 points हमने कुछ थोड़ी देर पहले देखे भी थे, and usually examiner is going to ask for one and the two advantages over SRAM or DRAM. Voice versa भी कर सकते हैं. Okay, difference between the SRAM and the DRAM. Most probably कुछ चीजें repeat होंगी, but there are some differences. Okay, DRAM, it's consisted of a number of transistors in the capacitor. As we know that it is going to, this SRAM is going to hold the flip-flops to hold the memory bit. Number 2 point, needs to be consistently refreshed. Doesn't need to be consistently refreshed. हमने 15 क्या कहा था, नैनोसेकंड्स का था, 15 माइक्रोसेकंड्स का था. किसी को याद है? मैं बैक साइड पे नहीं जा रहा हूँ. To hold that data in our DRAM. Microsecond, very good. Thank you very much. Okay, less expensive to manufacture than SRAM. Dynamic RAM is in a high, again in a high memory capacity, and the main memory is constructed from the DRAM basically, and consume less power. Now, the last 2 points of the SRAM is has a faster data access time than the DRAM, and memory cache uses make use of the SRAM. So this is basically the application of SRAM, where we are storing data in cache or cache memory. So as you can see that there are a few differences. Now we are going to start the basic concept of ROM, and this is again ROM is non-volatile memory. RAM जितनी भी थी वो volatile एक कंडीशन में ज़्यादातर volatile होती है, एक कंडीशन में नहीं होती। वो कंडीशन आपके साथ जब ऑन साइट क्लासेस होंगी तो याद कराइएगा, मैं आपसे बात करूँगा उस पर, क्योंकि इस वक्त एक्सप्लेन करना ज़रा सा मुश्किल होता है। वी डोंट हैव टू मच टू शो यू राइट नाउ. Okay, can be read from but not written to. ROM is a read-only memory. Read from memory. We do have certain ROMs. New ROMs are we can write it on as well. But once we are specifically talking about ROM, so we cannot write anything on it, but we can read data from it. There is a like a category of or type of a ROM जिसको हम कहते हैं EEPROM, erasable programmable read-only memory. As things are associated with the ROM, so we can erase and program this ROM as well. But the normal ROM is not going to, is going to have a fixed data. Okay, they're often used. Okay, flip-flop is out of your syllabus, but if you need to have some further information about it, flip-flop, well, like out of your syllabus means you need to only have some information about that there is a flip-flop, which is a device installed inside the static RAM. That's all you need to know. But if you think that you need some further information about it, we can do it in extra sessions, most probably in free sessions if you have. Okay, they're often used to store the startup instructions when the computer is first switched on. For example, ROM might store basic input-output system. इस हमेशा in words को जरा सा गौर से देखिए कि might लिखा हुआ है. Might store the basic input and output system. What this basic input output system? There is a problem with the laptops and the handheld devices that you cannot detach. आप हटा नहीं सकते. Whatever the keyboard you have or whatever the mouse you have. But if you are using a desktop computer and you're going to detach either the mouse or the keyboard from it and going to switch it on, sorry. So there will be a information or हम उसको कहेंगे interrupt. आपकी language के अंदर interrupt is going to generate from the computer that there is something wrong. My mouse is not there. My keyboard is not there. So this is just because of the ROM is holding, or basic input output system is holding that information, and it's non-volatile. It's not going to erase this type of a thing. अगर हम erase कर दें इस information को कि keyboard लगाओ ना लगाओ चल जाना, ठीक है? तो there is a trouble, how we can operate this computer. So some basic input and output information is stored in the BIOS. With the help of a ROM, we can read it. The data or contents of the RAM chip can only be read and they cannot be changed. That is, we did talk about it too much, and tends to be much smaller in the capacity, which means that it is going to hold some data on it. Okay, ROM is one of the embedded devices. ROM holds software that runs on that device known as firmware. आपने ये word बहुत ज़्यादा सुना होगा. मोबाइल को रिफ्रेश करने के लिए उसके firmware को आप रिफ्रेश कर देते हैं, रीसेट हो जाता है, बिल्कुल बेसिक पे आ जाता है, ठीक है? So as you can see, there is a ROM inside in your telephone and in your handheld device as well. In general purpose devices, ROM holds the software known as bootstrap, which contains the instruction that determine the hardware structure of the computer and instructional finding the loading of the OS. So less than a minute is remaining. So bootstrap is one of the